So this is a short video to show you how to carry out a supervised land cover classification using Erdas Imagine. As the base image, I've got a Landsat 5 multispectral image shown here as a false colour composite, with on the western side the edge of Greater Manchester, in the centre north the dark peak moorlands, in the southern part of the image the white peak area of limestone, and then on the eastern edge the edge of the city of Sheffield. And we're going to carry out a land cover classification with 6 classes: water, urban, quarry, moorland, grassland and forest. So first of all we go to the raster tab, supervised classification, and choose signature editor, and wait for the signature editor to load in the window. So the signature editor is where we generate the training areas for each of the classes that we are interested in. So here's the signature editor, and the first class that we're going to look at is the water class. So we'll zoom in on a reservoir here and start to generate the training areas. So to generate the training areas we go to drawing on the raster tab and then click on polygon to insert a polygon element. And now we can simply draw a polygon that represents the water training area. So the idea here is that we draw a reasonably large polygon that includes all of the spectral variability that's present for this particular class. So you can see here I'm avoiding the edges avoiding the edges of the water, so that we don't get pixels which don't belong to this class in the signature. Once we've drawn the polygon, double click to close it and add this signature to the signature editor. So we're going to call this class water, and we're going to give it a colour blue. And that's all we do for each of the 6 classes. So the next class that we'll have a look at is urban. So we'll use a training area on this side of Sheffield. So we again insert a polygon here. And within the urban area you can see there's quite a lot of variation, because urban areas are very mixed classes. They consist of areas of built up housing, etc., but also some red areas, which you can see here are gardens and small parks. So we try to avoid the larger areas of red. So this is now our urban urban training area, and we'll give that a grey colour. Next class we'll do is the moorland class, and this is an area of moorland here. It's very blotchy because this is an area of heather where the heather is managed for grouse, and so we have these strips of heather, checkerboard pattern, which are characteristic of some of these moorland areas. So this is the moorland class. This is mainly heather or kaluna, so we'll give it a nice purple colour. Next class we'll look at will be grassland. Now here in the white peak, the grassland areas are again quite mixed and consist of fields with different amounts of biomass, different amounts of grassland, and indeed some areas of agricultural fields which contain no grassland. So this training area encompasses the mix of different spectral responses for grassland areas. We'll give that a colour aquamarine. Grassland. So the next one we'll do is quarry. So here's a large limestone quarry near Buxton in the Peak District, and That wasn't very well drawn, so I'll try again. Avoiding the edges, but trying to include all the spectral variation within the class. This is Quarry, add that signature. So in this case we're only adding one signature per class. It is possible to have multiple signatures for each class so that we again capture that spectral variability. Now over here is an area of woodland in the Goit Valley, so I'm going to draw around this area of woodland here as my training area for the forest class. So this is our 6th signature, and that's forest, and we'll give that a gold colour. And that completes the training area generation. All we do now to produce the image is to classify using a supervised classification. So we give the output file a file name here. I'm going to call it peak class 6, and make sure it's saved to an area that you can save data to. We can change various parameters here, but to run the classifier in the simplest mode we now just click OK, and hopefully we will be able to produce a supervised classification using this these 6 training areas. So you can see now the process is quite quick. So every ignore this error, every pixel in this image now has been classified according to one of the 6 classes that we have defined. So now we can close this image and open the new image and have a look at it. So here's the multicoloured land use classification for the Peak District, and you can see that we've got the moorland quite nicely picked out. The water bodies are well classified. The grassland areas appear to be quite well classified. We have some urban areas in here, but you can also see that we have some areas here which are moorland areas confused with the urban areas. So it looks like the spectral signature of the urban areas are rather similar to the spectral signature of the urban areas, and so we would need to go back and refine the classification to try to improve it somewhat. So the main thing that you can see here is that the features with very distinct spectral signatures, and they include the water bodies here and the moorland, are very accurately classified, whereas some of the more mixed classes, like the urban area for example, are less well classified. So what we would do now is try to test the accuracy of this image classification, and that would require us to collect test points. And to do that, we would generate a random sample of points across this area and either visit or use aerial photography to test that, and use that to come up with an error estimate to see how accurate our classification actually is. If you want to change the colours, it's quite easy here. So if we go to the raster tab, table, show attributes, we can change the colours to something more meaningful. So for example, the grassland looks a bit wishy-washy, so if we make that a nice green colour, we can pick out the agricultural grazing areas. In the attribute table, the other useful thing is that we have excuse me, a histogram which shows the number of pixels in each for each class. So this histogram column here shows that there are 11,059 pixels classified as water. And we can use this histogram data to work out the total area of water, for example. So the pixel size in this image is 30 by 30 meters. So we'd multiply 30 by 30 by 11,059 to give the area in square meters for water. Okay, so that's a very quick and rough and ready example of how we classify satellite imagery using Erdas Imagine.